Welcome back. This is the continuation of the turbojet question. So here I'll just be finding the thrust of the jet. So you can just use the equation that, the question says fuel flow rate is negligible. So fuel flow rate is defined as the mass flow rate of fuel over the mass flow rate of air. And this can just be equal to 0. So the entire expression equals to 0. And we know that the thrust, F here denotes thrust force. The equation is as follows. I'll explain every time. This is the mass flow rate of air. This is the thing that equals to 0 because of the negligible flow rate. We found this last question. This is V6. Flight velocity, can easily find it. Sorry, actually it's already given. 150. And this term goes to 0 because we assumed a fully expanded jet. Which means which was this approximation here? Where Pj is P6 and this is P1 and they're equal. So if they're equal, they cancel each other out. This term goes to 0, so this entire term goes to 0. So the thrust is just left as this is 0 as well. So this is just Vj times 1 minus Vo, which is 150. This is we found as 783. Mass flow rate of air. Well, this is given in the question. 200. So 200 times 783 minus 150 comes out as 126.6 kilonewtons. Next part of the question. Find eta subscript p, which means propulsive efficiency. This is defined as power to the jet divided by power to aircraft. If you just bear with me for a second. Just looking at the data book for thermofluids. Sorry, these are flipped. So it should be power to aircraft divided by the power to the jet. Was just confirming. And the power to the aircraft is given as flight velocity times the mass flow rate of air plus the mass flow rate of fuel times the jet velocity minus mass flow rate of air times the flight velocity, all divided by the power to the jet, which is defined as a half bracket this term here and we know that mass flow rate of fuel is 0, so we're just left with these two terms for that specific term. So if we move the 2 on the top, VO, and we factor out MA, we have VJ minus VO on the inside, divide that by VJ squared MA factor out MA at the bottom. We don't need this bracket up here actually. Okay, so it's times. This is, take out the MA, we have VJ squared minus VO squared. These two can cancel. Move on to the next page. MP, we're left with 2VO, VJ minus VO. Now if this is a difference between two squares, we can factor that. These two cancel. So we're just left with 2VO, VJ plus VO. We can divide by VO to simplify further. Plus 1. Now, we have every term here. These two are constants. So NP comes out as, when you plug everything in, VJ was 2783. VO was 150 in the question, plus 1. That comes out as 0.322, which is 32.2% loss of efficiency. And loss of efficiency, just a fun fact, proportional, inversely proportional to the jet velocity. This is high, this is low. This is pretty high, around Mach 2 point something. So that's why you get a lower propulsive efficiency. Final part of the question asks to find the overall efficiency. Sorry, the thermal efficiency. And then the overall, which is just the product of the two, propulsive and thermal. And so the thermal efficiency that's just power to the jet over the calorific value burned, but here we use the lower calorific value, and that is defined as the mass flow rate of fuel times the low calorific value, and that was just the heat into the burner, which we know from the question. So NTH is 1/2 power to the jet, same as the last question. Power to the jet here was just this term here. So writing that out again. Mass flow rate of air plus mass flow rate of fuel, VJ squared minus MA VO squared over Q34. Moving to the next page. We know MF is 0. Factoring out MA, putting the 2 at the bottom. So MA, VJ squared minus VO squared, 2Q34. Plug everything in. We know this is 200. This was 500 times 10 to the 3. 150, 734. So plugging everything in, we get NTH as 0.592, which is 59.2%. So finally, the overall efficiency of the aircraft, or the engine, sorry, is just the product. Make sure to take the decimal, not the percentage. Comes out as 0.19, which is 19%. Alright, thanks for watching.